Hello everyone. So let's start with our very first problem on push-down automata. The problem is something like this. We have to accept a language and design a PDA for the same, which is of the form a raised to n, b raised to n, where n should be more than or equal to 1. So the simplest language that has to be accepted will be a, b, where n is equal to 1. Okay. Similarly, it can be AA, BB, triple A, triple B, and so on. The pattern has to be maintained, that is all A's together followed by all B's together, where number of A's should be equal to number of B's. In this case, it is 3. Clear? So, as always, we have to start the problem with the theory. So, for example, step 1 will be the theory of push-down automata. What exactly is a PDA? What are the various components of PDA, and so on. Step number 2 will be the logic for this particular question. This question is very simple and very straightforward. We have to simply calculate the number of A's and we have to push corresponding X's into the stack. We have already seen why do we push X for A, Y for B, and so on. So in this case, we have to compare both the powers of A and B. In this case, A has an equal number of B's. Similarly, number of B's should be equal to A. If this is satisfied, and at the end of reading all the inputs, if we reach the final state as well as the stack being empty, we will say that the logic for this particular question holds good. So to solve it, for each A we will push one X into the stack, and for the corresponding B we will pop that X from the stack. Clear? So the implementation begins like this, where M is nothing but the 7 tuples. Here Q will be made up of few states. We'll see what are the states Q0, Q1, and Qf. We'll see while solving. But first of all, let me tell you Q0 is the start state. Z0 is nothing but the stack initial symbol, that is stack top symbol. Alphabets are nothing but A and B. The final state is Qf, and the stack alphabets are R along with X. R obviously because initially there has to be some value, that is the initial stack symbol. So we are replacing Z0 by R in this case, and X is the symbol which is being pushed and popped from the stack. So these two are the stack elements, which are X comma R. So let's see what are the various transition functions. The transition functions go like this. Initially the stack is empty. Okay, so if the stack is empty, we are having just the symbol R on top of the stack. So in this case, we are starting with the state Q0. The input has to be A because it is A raised to N, B raised to N. So all the A's will come first, followed by all the B's. So what we need to do is, we are initially in state Q0, the input is A and the stack top symbol is R. As I had told you in the previous lecture, we always work in triplets, that is the current state, the current input, and the current stack top symbol. The combination of these three will tell the PDA where to move, either to push or pop or stay in the same state. Okay, so depending upon these three values, we see that we need to push an X for the corresponding A, because our logic tells that for each A we need to push one X onto the stack. So correspondingly, we will push one X on top of the R which was already present in the stack. Clear? This is our very first operation. The second operation is like this. We have already pushed one X into the stack. So now the stack top symbol is X and not R. Clear? So previously it was R, but now the stack top symbol is X. Okay. So now what will happen? The machine will remain in the same state Q0. This is very important to note over here. Generally, we do not change the state for a push operation. We only change the state for bypass or pop operations. I am saying it, generally we do so, but again, PDA logic differs question by question. So for each question there might be some different kind of logic. In this case, we are not changing the state for a push operation. Why? I will tell you later in the third and fourth transitions. Okay, so now we are in the Q0 state. The input symbol is again A only, because we are still reading the values of A's, because we haven't reached the end of A. We'll keep on reading it. The stack top symbol is X in this case, and we'll push one more X on top of this X. Why? Because we have encountered an A as the input and we are going to push an X for that A. So now we are having two X's on top of R. clearly this process will keep on looping up until we read all the values of a. Suppose we are having one more value of a over here, then we will loop this entire step once again. We will push one more x on top of the previous x present in the stack. So now we are having 3x and 1r on the stack. So we are done with the push operations. The machine is now in the Q0 state itself. So what is my next operation? As we all know that we keep on pushing till one extreme point. In this case, all the A's have been read. So now my popping operation shall begin. Because as I had told you in the previous lecture also, we need to accept the input and empty the stack also. These are the two conditions that will lead the machine to the final state. Otherwise, the machine won't move into the final state. Clear? So now my main objective is to uh, empty the stack. How to do so? By the popping operations, clearly. So as I had told you just now, 2 minutes back, that we don't generally change the state for pushing operations. Why? Because whenever we are making a transition from a push operation to a pop operation, or likewise from pop to push, we generally make a change of state. Over here, we were pushing continuously, so we were not changing the state. But now, whenever the first B is encountered after reading all the A's, we now know that we need to start popping up. So what will happen from Q0 state, my machine will make a transition to the Q1 state, and now as we are popping up, this particular value will be popped up from the stack, and the read head will point to the empty space created after popping the symbol from the stack. So an empty space is depicted by an epsilon symbol or a null symbol. Hence, Q0b, x will move the machine to Q1, epsilon. This popping operation will continue till we have read all the inputs in the form of b. Now just have a look over here. Here we made a transition from Q0 to Q1. So the next state or the next transition should begin from Q1 and not Q0. That is why we are making this transition Q1 over here. Clear? So Q1 b, x, that is all the remaining b's are read and popped one by one from the stack to create an empty space epsilon. So we are simply left with no values on the stack right now, because all the x's which were pushed for the corresponding a's have now been popped up after we have read all the b's. So now the stack is again empty with r on top. So the transition will be something like this: Q1 epsilon, because we are not having any inputs left, comma r, as the stack top symbol is r right now. So that will make the machine force the machine to make a transition to the QF state, and that is what is called as the final state. Hence, these are the transitions which we need to discuss. These are the 5 transitions. Based upon these transitions, our step number 4 will be constructed, which is nothing but the transition diagram. So have a look at the transition diagram. This is very much similar to what we have been doing in finite automata. There are 3 states: Q0, Q1 and QF. So that's why we had written Q is equal to Q0, Q1 and QF over here. I had written that well beforehand, but all you need to do is first construct the transition functions and then fill up the Q set over here, depending upon the number of states you have encountered. Clear? So now let's come back to the transition diagram case. We are having 3 states: Q0, Q1 and QF. How to make the transition? Simply refer the transition functions. The first transition function is Q0a on R goes to Q0 only, but this time it is pushing an X on top of the R. So what we need to do is, the transition is between Q0 and Q0 only. So there will be a self loop. Initially the input read was A, the stack top was R. After reading the input A, the operations which was performed was push operation and X was pushed on top of R. So how to represent it? It is very simple. Have a look over here. This is the transition which is representing that particular operation. So initially the input was A, stack top was R. We pushed an X on top of R. It became A, comma R slash XR. R slash XR is nothing but, it signifies that initially the stack was having R, which is now getting replaced by XR. Clear? The second transition is again a self loop, which is nothing but pushing on the successive A values, which is reading the A. Now this time we have already pushed one X on top of R, So the stack top is x, and we are pushing one more x on top of it, so it becomes x slash xx. Clear? After all the pushing operations have been done, we will start with the popping operation, which is shown over here. Initially, the input is b, the stack top is x. What we are doing with that x, we are popping it from the stack and it becomes empty. Clearly, the next operation will be the popping operation, but in a loop. So the same operations can be written over here. And finally, when we are not left with any A's or B's, we will simply make a transition to the QF state by reading null inputs. The stack top remains same, that is, we are performing a bypass operation and moving the machine to the QF state. I hope this is clear to you. If I'm going fast, kindly pause the video for few minutes. Go back to the exact point where I had discussed the logic, and try to recollect it and come back to this particular uh, position in the video. Okay, clear. So we are now finally left with the last step, which is simulation or example based upon the logic we have just now created. How exactly we need to solve it? It's very simple. Step by step we need to solve it. The initial state is q0. The inputs, for example, which I want to read is AAA triple B. I know that this is a correct input and it has to be accepted. So let's see how to accept it. The current stack top is R. So what will happen is we need to look at the first value, so that is q0 state on input A and top R. Basically, q0 state on input A and top R goes to q0 state only by pushing an x on top of the R. So what we just now did is based upon the transition function. So we have read this A value, so kindly remove this from the inputs. We are left with double A 5B, 3 B's. Continue the same process. q0 A on x will now again keep on pushing the x. It will be q0 A triple B XXR. Similarly, it will be q0 triple B triple XR. So now we know that we have done all the pushing operations. We'll start with the popping operations now. So what to do next? We now know that whenever we are making a transition from q0 to q1, that is from pushing to popping, we are eliminating one x from the stack. So it is nothing but q1, 1b has been read, so 2b's are left, 1x has been popped, 2x are left on top of r. In the same fashion, we keep on continuing doing so, and at the end we are left with no inputs and the machine has already moved into the final state, and hence it is accepted. On the other hand, I took one more example which I know is not abiding my language given, that is, it is not equal to a raised to n, b raised to n. Here n is 3 for a and n is equal to 1 for b. But we know that both the values of n has to be equal. In this case, they are not equal and it has to be rejected. But let's see how it goes. Again, following the logic, q0a on r, we have to push. So it becomes q0 aab xr. Till we reach this point, q0b triple xr. After popping that b, we are still left with two values and the machine has not made a transition to the final state yet. So hence, we reject this particular case because the machine has not moved into the final state and we are still left with few values on top of the stack. So hence, this particular example will be rejected. So this is how we solve a problem based on PDA. I hope this problem is clear to you and you will be able to solve similar problems based on PDA. I will be addressing few more problems on PDA because this is a very important topic from the exam point of view and many questions are being framed from this particular module. If you have not yet subscribed to my channel, kindly do so by clicking the red subscribe button below on the right hand side. This will keep me motivated to keep on continuing with such contents in the future also.